This is part 2 of the capital allocation line videos. In a previous video, we went ahead and calculations of these figures over here. Here, we're going to talk about the minimum variance portfolio and the optimal portfolio, which is the maximum Sharpe. Start with the minimum variance portfolio. First, we want to figure out or calculate the weights that we will need to know to apply to the stock fund and the bond fund and achieve the lowest variance possible. So these formulas here, this one and that one, weight 1 and weight 2. We're going to assign weight 1 to the stock fund. We're going to solve that. And once we have weight 1 with the bottom formula. So to get started, we start with, we're going to follow this formula. So here we have to be careful in that this is variance of the second asset. We assigned 1 to the stock fund, meaning that fund is the second asset. So we are going to start with the variance of the second. I will open a parenthesis so we can keep the top by itself or isolate. And the variance of the bond fund is what we calculated in the previous video, which is that one, minus that Greek letter rho is for correlation of assets 1 and 2. Here, the correlation of asset 1 and 2. The standard deviation of first asset times the standard deviation of the second asset. We're going to close a parenthesis and we're going to divide now with the bottom piece that we're also going to have. This is for that. So now we want variance of asset 1, which is the stock fund there, the variance. Always keep an eye on variance versus standard deviation. There's a common mistake made when calculating these formulas, getting the wrong one in there. Plus the of the bond minus 2 times the correlation times the standard deviation of the stock fund times the standard deviation of the second asset, which is the bond fund. And what we have just calculated is the weight of the stock fund and this portfolio that we're going to build with the goal of achieving the minimum variance, the lowest variance possible, is going to have to be 5.34%. And then we just do one minus that, following the formula here. Now this works this way because it's only 2 assets. If it was to be more than 2 assets, it's a different calculation. And there you have it. These are the weights that we need for the minimum variance portfolio. So now let's calculate the return deviation of that portfolio. So this one here, we're going to use the weighted mean formula, which is straightforward. You have seen this before. We're going to take the stock fund weight times the stock fund return, fund weight times the bond fund return. That is the expected return of that portfolio with a minimum variance. So standard deviation, we're going to follow this formula here. All right. Square root of, we have the square root, and I'm going to type everything we have in here, which is the weight of the first asset squared. So I'm going to take this and I'm going to square it. times the variance of the first asset, variance of the stock fund, plus of the second asset squared times the variance of the second asset, plus 2 times weight of the first fund times the weight of the second asset, the bond fund, times the correlation between them, times the standard deviation of the first asset times the standard deviation of the second asset. And we close the parenthesis. That is our standard deviation. The Sharpe ratio is going to be this formula. So we're going to open a parenthesis and we take the expected portfolio minus the risk-free rate and all that divided by the standard deviation of the portfolio. And that is our Sharpe ratio. Now, we're going to do something similar than we just did, except variance. We are looking for the portfolio that's going to give us the highest Sharpe ratio. We want the highest Sharpe ratio, and that's a measurement of efficiency. So very similar to using this formula for the minimum variance, we're going to use this formula for the Sharpe ratio. Okay. What I'm going to do is I'm going to bring it in. Allocation, and we're going to go over it. This here is what the formula is going to look like. This is what you have here, the top part, that W1, that is the weight for the first asset that we want in order to achieve the highest Sharpe ratio possible. What you're seeing here is K4, the expected return of the stock fund, of the fund one, that's you see here, minus the risk-free rate, that's the C10. We have that in parentheses, just like they have it here. Means the variance of the second asset, M5. So we have is, I'm going to repeat that first piece, the expected return of the stock fund, which is our asset one, minus the risk-free rate. That's in parentheses. Then we multiply by the variance of, which is the bond fund. These things have to be calculated across that way in order to capture those covariance they have. All right, then minus, that's the minus, you see that minus in there. We're going to go with expected return of the second asset. The second asset. Let's go back in there. Expected return of the second asset minus the risk-free rate. The bond fund here is the risk-free rate. Covariance. The formula dictates variance. So we take that and we times it by the covariance. Now that's the top part. So we want to close that parenthesis. And we do the division sign. So now we're going to do the bottom part. Again, we start with the expected return of the first asset, which is this, minus the risk-free rate, times the variance asset, a plus sign, the expected return of the second asset, That's this here, the bond, minus the risk-free rate times the variance of the first asset. Minus, now we're down here. We're here now. The return of the first asset. Minus the risk-free rate. An asset. Minus the risk-free rate again. Times the covariance. So this minus sign that you, that's the minus sign you see here. Now you get a of where it's located on the formula. So from here to that sign, it's from here to there. Then the right-hand side, it's the other second piece. That's what you have here. And you can just follow the letters and the numbers, follow the formula, and they'll all fall in place there. So what does that tell us? That we need 34.0% on the stock fund, and the bond fund again will be 1 minus that piece, and that will achieve the Sharpe ratio. Now, what I'm going to do, I'm going to do a little shortcut, paste, but we're not done. We just got to fix a few things. Here is going to use the weights like we use above there. However, it has to be multiplied by the returns on each one of them. Notice that it was the weights and the returns. But since I copy and pasted, I just got to fix that. 2 K4 and 2 M4. Now weight times return plus weight times return. Have that formula in place. That will be the expected return of that portfolio. Standard deviation of that portfolio. We could copy and paste, but there might be a lot of to do that. But what we can do is learn about the dollar sign practice. So P5 is the weight, so we can let that move. However, 5 is the variance. We don't want that. Press F4, I get $2 signs there, which is going to allow me to lock in the sale when I move it. I want R5 to move when I change it. That's fine. But M5, I don't want it to move. The variance. The 2 is static. P5, that is the weight again. I want that to move. R is the weight. I want that to move. But K9, the correlation. So I'm going to put dollar signs around it to lock it in place. 6 is a standard deviation. Same thing. I don't want it moving because I want it to stay there. And I can do that too. This is a way to lock some cells in place while allowing others to move when you copy and paste on a different location. So with this, notice it's using now the weights down here, but it kept these in the places where I want them to be. So the of this portfolio is 6.03. I copied and pasted it, but I didn't get anything in place. The one that should have been locked would have been the risk-free rate. So we fixed it. We gotta make sure taking the expected return minus the risk-free rate divided by the standard deviation, just like it says on this formula here. 0.6137. The idea here is that this Sharpe ratio is higher than this one. So you have a more efficient portfolio. It's going to have a slightly, well, could be higher, slightly higher in this case, standard risk. But the increase in return was greater than the increase in is more efficient. That's it for this video. We will continue the spreadsheet on the next part.